Okay, this is the next question. We have to obtain the orthogonal basis. Okay, this is the requirement. Now we are given this matrix. So 1, -1, 2, -1, 1, -2, 2, -3, 5, -3, 2, and -5. Okay, this is a matrix given. Now I'm going to rewrite this as column 1, 1, -1, 2, column 2, -1, 1, and -2, column 3, 2, -3, 5, column 4 is -3, 2, and -5. So we have 3 columns. Now observe column 1 and column 2. Column 1 and column 2. So I can actually rewrite column 1 as negative times of column 2. Negative times negative is positive, so we get 1. Negative times 1 gives me -1. Negative times -2 gives me 2. So one column down, meaning is I'm able to write one column in terms of the other. So we have only 3 columns that are actually truly independent. Now I cannot really confirm their independence. Now I'm just telling, or I would say making that statement before we embark on the next iteration. Now let me consider the other column C4. Now C4 has got -3, 2, and -5. Now can I write C4 as A times C1 positive B times C3? Now A times C1 is 1, -1, and 2. B times C3 is 2, -3, and 5. Okay, so I need to get -3. So clearly it's possible. I need to get a positive 2. It is possible. I need to get a -5. Still it is possible. We have to extract A and B. So the objective is not to find the constants A and B. The objective is to find the number of columns that are truly independent. So what is the conclusion? The column space is spanned only by 2 independent vectors. And what are those? They are C1. We see C1 being present everywhere, and C3. Okay, so we need orthogonal basis with 2 vectors. So that is a requirement. Having given you that statement, so let the vectors be u1 and u2. Now clearly u1 is going to be equal to c1, and which in turn is going to be equal to 1, -1, and 2. Okay, now we need to extract the orthogonal vectors. Okay, we need to extract the vectors from here. So how do we do that? First we find the norm of u1, which is going to be root of 1 squared positive of -1 squared positive of 2 squared, which is going to be square root of 1 positive 1 positive 4, which is equal to root of 6. Okay, so the required orthogonal vector, is going to be equal to u1 over norm of u1, so which is going to be equal to 1 over root of 6 times 1, -1, and 2. So this is going to be our orthogonal vector. So one vector is already found. Let's move on. Now let me name this as sum e1. Okay, moving on, let's go to the next page. Now we have this C3. Okay, And E1 is 1 over root 6, 1, negative 1 and 2. Okay. Now what we want to do is we want to orthogonalize C3 against E1. So how do we do that? We get the dot product. So that means 2, negative 3, 5 dot of 1 over root of 6 times 1, negative 1 and 2. So this is going to be equal to 1 over root 6, 2, 3 and 2 times 5 is 10. Okay, and this is equal to, so this is the dot product, so we will have the sum of 2, 3 and 10, which is nothing but 15 over root of 6. Okay, so I'll write that C3 dot E1 is 15 over root of 6. Okay, step 2, we compute 15 root of 6 times E1. So this is going to be 15 root of 6. E1 is 1 over root 6 of 1, negative 1 and 2. So it's going to be 15 over 6, 1, negative 1 and 2. 3 divides here, 2 times 3 divides here 5 times. So this is 5 over 2, negative 5 over 2. And this is going to be 5 over 2, 5. So this is what we get. Okay, so after this, what we have to do is, probably you can simplify this. 5 divided by 2 is 2.5, negative 2.5 and 5. Okay, the next step is we compute. We started off stating that u1 and u2 be the vectors, so we compute u2 now. U2 is actually C3 negative of 2.5, negative 2.5 and 5. Okay, so this is going to be C3 is 2, negative 3 and 5 minus 2.5, negative 2.5 and 5. So this is equal to 2, negative 3 and 5. And if I were to push in the negative sign, it's going to be negative 2.5, positive 2.5 and negative 5. So this is equal to 2, negative 2.5, negative 3, positive 2.5 and 5, negative 5. So this is equal to negative 0.5 and this is again equal to negative 0.5 and this is 0. I can rewrite this as negative 1 over 2, negative 1 over 2 and 0. I multiply by negative 1 and this is going to give me 1 over 2, 1 over 2 and 0. Now I calculate the norm of u2. So this is equal to root of 1 over 2 squared plus 1 over 2 squared plus 0 squared, which is equal to root of 1 over 4, positive 1 over 4, which is going to be 4 and 2 over 4 root. So it is going to be root of 2 over 2. This is what I get. Of course, I can rewrite this as 1 over 2 is going to be root of 2 times root of 2. You have a root 2 there. They get cancelled, giving me 1 over root 2. So this is going to be my norm of u2. Okay, so my E3, or I would say E2. So therefore the other vector is going to be, I have to take u2 divided by norm of u2. Okay, so my u2 is this. So 1 over 2, 1 over 2, 0, and you're dividing. So divided by 1 over root 2. So if I were to divide by 1 over root 2, this is going to be equal to root 2 over 2, root 2 over 2 and 0. So which in turn is going to be equal to 1 over root 2, 1 over root 2 and 0. So this is my E2. So therefore what are the vectors? So let me write the vectors down. Therefore the bases actually, right? Hence the orthogonal basis is what? So I've got 1 over root 6, negative 1 over root 6, 2 over root 6. This is 1. And 1 over root 2, 1 over root 2 and 0. Okay, so clearly we know the solution and the correct choice for the question.